Hi everyone. We're going to pick up with production and costs right where we left off in class last week. So the next distinction I want to make is about the short run and the long run. And in economics, when we distinguish between the two, there's one important factor, and it has to do with whether or not there is a fixed input. So in economics, it's not a matter of time necessarily. It's not like the long run is more than 6 months and the short run is 6 months or less. That would make it really easy. That's not how we distinguish. In the long run, every input is variable. You can adjust the size, and whether or not you have it of every single input. So in the long run, if you run a pizza shop, you can move to a bigger facility, you can move to a smaller facility, you can close it down altogether, you can add ovens. In the long run, all inputs are variable. So if you thought about them as dials, like as a big mixing board with lots of dials, you could turn them all down to zero. If every one of those, dials, volume controls on a mixing board controlled one particular input, you could dial them all down to zero, or you could dial them all up to the max, or anywhere in between. So in the long run, all inputs are variable. In the short run, at least one input is fixed. So if you run a pizza shop, your plant size, right? Your shop size is fixed. In the short run, you can't change it. If you have a certain pizza shop next week, your pizza shop's going to be the same size. Now, how long would it take you, if you're in a strip mall, how long would it take you to lease the store next door and take down the wall and expand? I don't know, 6 months, a year? What's the timeline, to do that? What's the timeline to move to a different facility? What's the timeline to shut down altogether, to exit the industry, as we'll call it later, to completely sell off all your assets and get out of the business? So you can see how the difference between the short run and the long run would be different for different kinds of industries. In the petroleum refining business, it can take a decade to get all the permits and to physically build a new oil refinery. So expanding or selling off or adding another one, that could be, it could take a decade to do that. If you're talking about a food truck, if you have a business where you have a food truck and you're thinking about adding a second food truck to your fleet or selling off the one that you have, I don't know, it might be a matter of weeks. Like if I don't know, if I went on Craigslist or eBay today, could I find a food truck for sale in Wichita, and make the deal, go there, pick it up, drive it back, in 2 weeks, maybe I could be up and operating out of my second food truck. I don't know. But understand that it's not a specific length of time. It has to do with whether or not you have at least one fixed input. Do you have at least one input that you cannot change, between now and whatever time frame that is? So one sort of related question, the law of diminishing returns. We've talked about this before. Is this a short run or a long run concept? Law of diminishing returns. It says as you add more and more variable input to a fixed input, output will go up by smaller and smaller amounts. So I already said enough to figure that out, right? If you have to add a variable input to a fixed input, if there's a fixed input, then it was in which time frame? It is a short run concept, right? This is a short run concept because it has to do with adding variable input to a fixed input. And if there is a fixed input, you are in the short run. So, all right, there's your distinction on time. There's the cartoon that we talked about before. Now, let's talk for a few minutes about costs. One of the things that we do well, I think, in econ, at least in terms of the names and the concepts, is distinguishing between the kinds of costs associated with fixed inputs and variable inputs. So you have fixed and variable inputs, and then you have fixed costs and variable costs. And not surprisingly, fixed costs are the costs associated with your fixed inputs. Variable costs are the costs associated with your variable inputs. And total costs are just the sum of those. All of your costs have to be associated with either fixed inputs or variable inputs, right? So fixed costs plus variable costs equal total costs. Now, another way that we can sort of slice and dice the costs, we can think about them in terms of marginal costs, right? Cost for an additional unit, or average cost per unit, right? So marginal cost is the change in total cost as quantity increases. And then average cost, well, that's total cost divided by quantity, right? So how many units do you produce? Take your total cost, divide by that, and you get your average cost. But marginal cost is the incremental change in total cost as you produce another unit. And then one last thing, the relationship between marginal cost and average cost. The marginal always drags the average along. Right? So the marginal always drags the average along. So we'll circle back to this, but we're going to see eventually that your average total cost curve looks like this. And because of that, your marginal cost will intersect the average total cost at its minimum point. So what that means is that if the marginal always drags the average along, when the marginal is below the average is falling. And when the marginal is above the average is going up. Now you know this, right, in practical terms already, because if you have your overall cumulative GPA, that's your average measure, right? That's your average grade from your college experience. So you have your GPA, right? That's your average measure. But then each semester you get individual grades, you get marginal grades, right? So each semester you get marginal grades, right? Incremental grades in those particular classes. And so if in a particular semester you're doing really well, and so if your marginal grades are higher than your average, what happens to your average? Well, it goes up. Right? If your grades in a particular semester, those are your marginal grades, are higher than your overall GPA, it pulls your GPA up. The marginal drags the average up. On the other hand, if you have a really rough semester and your grades in a couple classes are lower than average, what happens to your overall GPA? It pulls it down, right? So the marginal drags the average along. All right. I want to get to this average total cost curve. So this requires a little bit of fun drawing here. So you're going to need sort of a 2x3 matrix. You're going to need enough room for 6 graphs. We're only going to draw 5, right? But you need to have them. Oops. These are not quite as straight as I would like. All right. So first we're going to talk about total fixed costs and total variable costs. And we're going to think about that as we produce more output. So Q in this case is for output, right? Number of units produced. When we drew graphs in the first half of this chapter, last time, Q referred to, and this axis referred to the number of units of variable input. Now we're switching and thinking about our costs in terms of the units of output. So that's why I'm emphasizing this here. This is the number of units produced, right? This is your output. So your total fixed costs. How does your total fixed cost change with the level of output? Well, it doesn't, right? That's the nature of fixed costs. Your fixed costs are the same whether you produce a couple units or 100 units or 1,000 units. So the nature of fixed costs are that they are constant. So your fixed costs, or your total fixed costs, look like this. Let's see if I can make that F a little bit better. There we go. Your fixed costs look like this. They're constant. Now, what about your variable costs? Well, your variable costs do increase, right? As you have more and more, you produce more and more output, you have to hire more and more workers. You have to get more dough and more, sauce and cheese, or whatever, whatever output, whatever product you're producing or service you're producing. And so there may be a little bit of wiggling, at first, based on, it may go up, and then it may go up a bit more slowly because you got some gains from specialization. But eventually, it's going to go up faster and faster, and it's going to increase at an increasing rate. Because in order to produce more and more output, you try to add more variable input, but you have diminishing returns, and so it starts to get very, very difficult to produce more output, so it becomes more and more expensive. Right? Your variable costs go up faster and faster. So these are your total variable costs. So there's your total fixed cost, and there's your total variable cost graphed against quantity of output, right? The number of units that you produce. So now what I want to do is divide these by Q, because what I really want over on this side is your average fixed cost and your average variable costs. So I want to take fixed costs and divide by Q. I'm going to take variable costs and divide by Q. So how many units of output do I produce? Well, I take my total cost measure, divide by the number of units of output, and that will give me my average cost. Now, here's the thing about a fixed cost. If you start dividing it by Q, what happens to your average fixed costs? And so I know basketball season is pretty much over, but if we had talked about this, back in November, or in a traditional year, and you were looking at the beginning of a winter, you might want to watch some basketball. A new flat screen is expensive, right? So maybe not as expensive as they used to be, but so maybe you're thinking, should I pony up $600 for a really big flat screen TV that will make the game come alive? You're like, well, that's a lot of $600 is a lot of money, but if over the course of the, if I only watch one game, that's really expensive, right? $600 per game. But if I watch two games, what happens to the average cost per game? Well, all of a sudden it only costs me $300, right, per game. What happens if I watch a third game? Well, then my average cost, right, of the TV per game is now only $200. What happens if I watch? So what happens if I watch 300 games? If I watch 300 games over the course of the winter, my average cost per game is only $2. So the switch back here. If I produce just one unit, right, my average fixed cost is the same as my fixed cost. But if I watch or produce just a second unit, my average fixed cost drops by half. If I produce a third unit, it goes down to a third, right, and then a quarter, a fifth. And so what happens is that average fixed cost falls very, very quickly until it gets very, very small and asymptotic with the horizontal axis. So this is my average fixed cost. And I didn't label my axes here, did I? This is also Q, right, for units of output. So my average fixed cost, if I take my fixed cost and divide by Q and then graph it against Q, it's going to drop off pretty quickly. Now let's do the same thing with my variable costs. My total variable costs are going up, slowly, and then they go up faster and faster. So since variable costs are increasing at a rate that's greater than 1, right, then even though I'm dividing by Q, it's still going to be increasing in this range over here. So what we're going to see through the math is that your average variable costs are going to look like this. Right? Because they're going up so fast, even when you divide by Q, it's still going to be increasing in this range. So it may be fairly small and inconsequential for a while, but once you get to this section over here, where it's increasing quickly, average variable cost will be increasing as well. And then this is the exciting part. This is where we were headed. I wanted to get to average total costs. So let's go back down here to something we said before, right? Total costs equal fixed costs plus variable costs. Now let's do a little algebra. Okay? What happens if we divide both sides of the equation by the same thing? Well, they're still equal, right? Total cost divided by Q has to be fixed cost plus variable cost divided by Q. And now I can distribute that too, right? I can distribute that fixed cost plus variable cost over Q. I can make it 1 over Q times fixed cost plus 1 over Q times variable cost. So that's really fixed cost over Q plus variable costs over Q. And I had over here on this side total cost divided by Q. And so if you take some measure and you divide by Q, you get the average, right? So what you get is average total cost. Total cost divided by Q gives you average total cost. Have to be fixed cost divided by Q. That's average fixed cost plus variable cost divided by Q. That's average variable costs. All right, so this is not really earth-shattering, but I'm just showing you the math to prove, right, that if total costs, right, if total costs equal fixed costs plus variable costs, right, so if all of your costs can be classified as either fixed costs or variable costs, then average total costs is also equal to average fixed costs plus average variable costs. So why is that important? Well, here I have average fixed costs and here I have average variable costs. So if I add these up, I can get the average total cost curve. So basically what we're saying is at a particular quantity of output, right, I just need to add the average fixed cost plus the average variable cost, and that will give me my average total cost. So at 1 unit of output, my average fixed cost is really, really high, and my average variable cost is pretty low. And so when I add those together, if this is my, if this is my average fixed cost and I add my average variable cost on top of it, I get something like that. And then at 2 units, right, my average fixed cost dropped a lot. My average variable cost was still fairly small, so it's right there, right? And then at 3 units, my average fixed cost was even smaller. My average, my average variable cost gets added on top of that, and I'm there. Right? And so over time, my average fixed cost is getting less and less important, right? It's getting smaller and smaller, but my average variable cost is going to start increasing, right? So as you add these together, you end up with an average total cost curve that looks something like this. Has some sort of lumpy U shape. And so that's what the average total cost curve that I drew for you up above when I was looking at the relationship between marginal and average measures. It was kind of U-shaped. This is the sort of the proof to get you there. So the takeaway, right, from all of this is that average total cost is going to be somewhat U-shaped. All right, let's break it here just so that we don't have videos that are too long, and then we'll pick up with scale and then